Hi everybody, Professor Gassimi here, and in this component of the lecture, we're going to be answering the question, what are domains and what is a DNS? So first, what's a domain? Well, a domain is the string that we type into the web browser to gain access ultimately to the content we're interested in observing. So for example, www.google.com, www.msu.edu, developer.mozilla.org, as I'm showing there on the right. These are all domain names. Okay, now these domain names, you might notice they all have dots in them, right? And that's because each of the components that you see that are between those dots are actually meant to represent something different. And the way that you read a domain name actually is not from left to right like you would in English, but it's actually from right to left. That is to say, you start with what's on the right. So in the case of the example we have there, the way you're meant to read developer.mozilla.org is to first have your eyes look all the way on the right and see that it's a .org. Why is that? Because .org implies it's an organization versus .com would imply it's a company and so on. Now, there are actual implications and restrictions around these TLDs or top-level directories, the stuff all the way on the right. Not anybody can create a .gov address, for example, or not anybody can create a .edu address. Those top-level directories, you can enforce policies on them for who can and who can't have access. Now, these top-level directories, or again, TLDs, can contain up to 63 characters, although most of them are around 2 to 3 characters in length. .org, .com, .edu, etc. Now, anything stepping away from the .org all the way on the farthest right-hand side of the example there and moving to the left, we get first Mozilla, and then if we move one more to the left, we get developer. Well, those are what are called labels. Anything that follows that top-level directory is called a label. And it's a case-insensitive character sequence between 1 and 36 characters in length. It can contain special symbols and whatnot. And the domain, to be clear here, can have as many labels or components as you want. I know it's common to only see 3. We see, mail.google.com or, www.mail.google.com or whatever, but you can actually make that as deep as you want. You could go 5 or 6 or 7 labels deep in terms of the domain name. Now, we know what a domain name is. Well, what's a domain name server? Well, a domain name server is basically the phone book of the internet. Okay, it helps direct traffic on the internet by connecting domain names with actual web servers. So when you say that you want domain.com, a domain name server basically returns the IP address for whatever domain that you're looking for, so you know which machine to go navigate to get the content you're after. And when the user enters the URL in their web browser and the DNS connects that URL to the IP address of the actual server, this is called Dns Name Resolution. And the way that this works is through the DNS server recursively querying various name servers, okay? So a name server that's where the actual records of DNS are stored. And the way it works is something like what's illustrated on the right-hand side. I'm going to step you through this. So you are some machine, you're interested in getting access to some content. So what you do is you ask, for example, your local server for an address, like, hey, I want www.mit.edu. This goes to your local DNS server, and it doesn't know the answer, but what it can do is, because you asked for www.mit.edu, it first goes to the edu server and it says, hey, to the root server, and it says, hey, I'm looking for a www.mit.edu. Can you tell me if you know this? And the root server will say, well, I don't know actually what the IP address for this is, but I think I can send you to the machines that handle .edu, and they might be able to tell you. So this comes back, and this gets resent to the .edu servers. Now, these .edu name servers are again asked, well, hey, do you know where www.mit.edu is? and they will say, well, I don't know actually specifically where that IP is, but I do know where mit.edu, the server that handles that, and they could probably tell you. Again, it sends it back, it goes to this one, and this process repeats until finally whoever is responsible for that particular record is able to pass it back to the local DNS server, which gives it back to the app so you can go fetch the content. Well, what exactly is a DNS record, right? We discussed that, these DNS servers basically make recursive calls to these things called name servers, and those name servers have DNS records. Well, a DNS record is basically just a way to associate a given name with a given web-based service. Okay, there are a lot of different entries in DNS record systems. I'm showing you a subset of them here on the right, the common ones: A, quadruple A, Cname, MX, and so on. For the purpose of this class, you're probably going to use 3, maybe 4. Those are what I'm showing on the left-hand side. The first is A records. These map basically a domain or a subdomain to an IPv4 address, which we've already spoken about. Now, if a web server is using an IPv6 address, that's when you use the quadruple A record instead of an A record. The second thing that you'll want to know about is something called the Cname record. This is used to associate subdomains to the primary or canonical domain. For example, you want folks to know that www.example.com is actually the same thing as example.com, right? They should return the same content. And so the DNS record system needs to be made aware of that through a Cname record. Okay, and the final one is our MX records, which are used to associate a domain with an email service. Okay, so if you wanted to add mail, for example, to your example.com, that's what you would use. What do these actually look like in a nuts and bolts sense? Well, if you had purchased a domain name and you had access to a interface through whoever provided that to you to edit DNS records, they'd have a table that would be editable. It would look something like this, right? And so you might put, for example, a couple of A records to say that example.com points to this IP address, 203.0.113.55. And that my subdomain, actually, some subdomain, maybe it's subdomain.example.com in this case, points to some other IP address. Okay, but that www is .example.com is actually just an alias of example.com. Okay, and maybe you'd set up some mail stuff here too. This is sort of what a DNS record ultimately looks like. Again, the major takeaway I want you to have from this is that there's these 3 kinds of records. And if you're going to actually deploy your service on the web and you want to give it a domain name, you're going to have to probably edit these DNS records. Now, one of the things that you see here, in addition to status, which just says whether things are up, is this thing called TTL. I want to take a moment to speak about that. Now, because of this recursive way that information is collected on the locations of these records, when you want to update the records, there is a certain amount of time that it takes for that record to go into effect. That is to say, when you add entries to a DNS record, you don't instantly make the change and the entire planet now knows that this website maps to this IP address. Okay, the TTL, or time to live value, is what determines how quickly those changes take place on the DNS record. In the case of a main server, the registrar determines the TTL value, and it generally is not something you can change. They might allow you to put an entry in, but it won't change the fact that they ultimately control that. Practically what this means and why I'm bothering to tell you is because when you switch to a new name server, it can take from anywhere from minutes up to days or longer for those changes to take place. So if you're going to change name servers, just understand your website could be down for a period of time and don't panic. If you ever want to know about the propagation of your website across all the DNS servers on the planet, there is actually a website called Whatsmydns.net where you can come in and put in your website name. I put in gasimi.xyz, which is my personal website, and you can see which servers you see were able to resolve this particular A record. And you can see actually there's 2 that were not able to resolve it, interestingly. So, okay, well, we know what domain names are. We know what domain name servers are. We know what name servers are now. Well, what is a registrar and a registry operator? These are basically where domains are purchased and registered, the name servers are specified, and the DNS records are made. So you as a person, you're called a registrant. You go to a registrar, which are people accredited by ICANN. This is sort of the nonprofit big boss that coordinates the domain name system. These registrars work with registry operators. These are the ones who maintain the records of domain name registrants and the DNS settings. Sometimes the operator and the registrar are the same entity, by the way. Depends on who you're working with. I think AWS, for example, plays both of these roles. And then ultimately, these report back to ICANN and follow their rules and regulations. Okay, so the major thing I want you to conclude from this is that domain names provide a readable address for any web server available on the internet, and that DNS directs traffic on the internet by connecting domain names with actual web servers. I also hope that by taking a little bit of time to show you those DNS records, if you get to a point later in the semester where you decide you want to connect a domain name to your particular web application, some of that will be a little bit less mysterious.